see, tell me what an address to join. Let's see if he's in though.
Milo's always here, but he's usually incognito somehow.
Yeah, but he's somewhere hidden normally. Let's see it going through the review there.
I just saw Tracy.
Yeah, Tracy popped up for a minute there. How you doing, Alan?
Good. I'd like to join in on some of their classes, but they don't Zoom them or anything. You got to be in person.
No, you don't. They Zoom them. I see them once a month. Matter of fact, the next meeting is the 16th.
The Colorado group, last time I talked with them, they said they don't do any videos.
I've been Zooming them for 2 years, 3 years.
But you're special.
No, you can get Zoom, man. There's probably about 8 of us that Zoom all the time. It's not just me. There's about 8 or 9 guys that Zoom.
That's the flyweight saying they don't want us in there, Alvin.
I think what he's talking about is when they hold their get-together 3-day show-off.
No, it's once a month. They have a meeting.
No, he does every year, about maybe once or twice a year, a get-together lesson learning thing, and that is not Zoomed.
Every meeting there's lessons learned. I mean, he makes a little video, and you can always download the meeting later, and has the videos in it, and it's always some sort of presentation. It's pretty good.
No, I'm talking about his get-together that they do. They have too many people there and too much going on to try to Zoom that particular event. And it only happens like twice a year.
No, I haven't seen that, sorry.
Good evening, everybody. This is Tracy. Welcome to the class. Whether you have CCAM Pro or not, you're still welcome to the class. I'm recording this, and again, this is simply a wide open format. There's no plans exactly what we're going to do. This is open for Q&A. So if you have questions or want to see how to use the software or anything, please let me know, and that's what we're going to do tonight. So let me make a couple announcements first, and then we'll start. First of all, I know many of you are looking for the display table files. I'm just wrapping it up, but I'm putting them into CCAM Pro. So there's a little bit of a delay here because I'm waiting for an upgrade from the programmer so I can release the CCAM Pro upgrades, and it'll have the project file in it. I can actually send you the project file as an export before the update, which is not a problem. So as soon as I get that in, I'll probably release the display table files first if they come before the CCAM Pro update. I expect that at any time. Let's see, is there anything else we need to announce? Nope, those are the two, the CCAM Pro update and the display table. So if you're new and you don't know what I'm talking about, we have what we call an onboarding project. It's part of our training that we want to release to everybody that buys a machine with the 3 workstations. That shows you how to do something on all 3 workstations, the turning, the joinery, and we're doing some inlaying a tabletop and doing some other things, and compile that into a project. It's perfect for CCAM Pro. If you don't have CCAM Pro, you can still do it with Vectric and Conversational CAM Essentials. So if you're interested in acting as a beta tester, you can drop me an email at tracy@legacywoodworking.com. Many of you have already emailed, and we have taken those emails and tagged them, so you will get an email about the update here very shortly. If you haven't heard anything yet, be patient, it's coming. Okay, any questions then with Conversational CAM Pro for us to get started?
Yeah, I have a question, Tracy.
Yeah.
The other day I was doing a taper, and the angle of the taper exceeded the capability of the B-axis tilt, and I got a script abort notice as a result. So I ended up doing a contour instead, but I had to define a radius which I gave a value of 1,000,000 inches,
Okay.
which for all intents and purposes would be a straight line.
Pretty flat, right? That's right.
So I was just wondering if there was a different way to do that.
No, if it exceeds the maximum taper angle of your adjustable bed, the only way to do it is to do a contour. Now, there's two ways to do the contour. One is turning / contour, where you actually put in starting point diameter, ending point diameter, and an arc value of 1,000,000 inches, for example. The other way is to do the vector turning. So you would, in Aspire, you simply draw a straight line and you save that file out like we've done with the other turnings, and then in CCAM Pro you import that as a vector turning, and it'll do that. Does that make sense?
Yes.
And if you want, I'll show you the two. If anybody would like, I'll be glad to show you the two options. Okay,
Go ahead.
I'm muting everyone. We have a little bit of background noise, so I just muted everybody. So if you do have a question or want to see something, hit your space bar. And for the viewers who maybe are not following exactly how he was approaching that, let me just show you real quickly. All right, so if we go into projects, I've got a test taper. Let's just use that. And if we look at the parts, I'm going to select a workstation. We'll go to manage parts. Here's our test taper. It's 48 by 7.5. This is a big piece. This is what I was doing with Dave Gray. And so let's go ahead and look at well, this might be a little bit big. I'm going to add a new part that's not as big. Okay, so I'm going to call this the new part. Not as big. Okay, so we're going to make this, let's call it 16 inches long, and let's call it 2 inches in diameter. Make it 4 sides, or it could be rounded. All right, so now we've got two parts over here. Let's go with the new part, not as big, here, and we'll manage our tool paths. So you have three options. One is turning and turn around. And now there were some questions about this earlier today, so maybe I should show all three of these real quickly, unless there's other questions that are more important. But I'm going to put in here, we can do turning, round contour, and we can also import vector turning. All three of these toolpaths will do what we're trying to do. The first one, you're going to pick a tool like the surface planing bit, not like the surface planing. You definitely want to pick the surface planing bit, like we always do. And we're going to start a position at, say, 1 inch, and it's going to be 2 inches in diameter, and we'll go to 16. Okay, so this is a little different than CCAM Essentials, in that in Essentials you put in the starting position and the starting diameter, then the ending position and the ending diameter, and they could be the same diameter. Conversational CAM Pro, you do not. You simply put in starting point, the diameter you're going to turn it to, and the ending point. And it will turn this round. Then down here at the end, it's going to ask, is this part tapered? Okay, if you say no, then it's just going to turn it around to 2 inches. If you say yes, so this is what's different about the original conversational CAM. You're going to put the starting position. Let's say we start at 1, and our diameter here is going to be 2, and we're going to go to 16. If we're going to go the full length, we'll do the whole thing. And let's say we're going to go to 1.5. Now this is asking, okay, that's the overall taper. Where do you want to cut in that taper? This was not available in Conversational CAM Essentials either. So you could start at 1 inch, or you could say, I don't want to start until 4 inches. And I want to end at 12 inches. Okay, so you've established the taper, but you don't have to know the exact diameter at those two positions. Just you can put anything on there. The advantage of this is, maybe I should show you why that it is designed this way. I'm going to open up Aspire real quickly, and let's just create a new part. And I don't really care what it looks like. I'm just going to draw something up here. So let's say that you're tapering apart and it goes, okay, I do care what I'm doing. Okay, single side. Let's make this 16 by 2 by 1 by -1. Okay, so that's the part that we just designed. All right, so we said start at 1, so I'm going to draw a line right here, and we're going to move this down 1 inch. Okay, along the x-axis to 1. Okay, so if we're going to start at 1 and we're going to taper down here, and we're going to start at 2 inches, and down this end we were going to go 1.5 inches. So I'll draw 1.5 inch line there, and then I'm going to just take this and we'll put it right here at 16, right at the very end. Okay, and then if we draw the taper in here, it's going to go from there to there, and if we draw the other end, it's going to go from here to here. Now, if that's your overall taper of everything, but you're going to take and cut and machine let's use an arc right here. Let's say that I'm going to machine a bead right here. I'm going to use a point cutting round over bit or something. Okay, let's do that. And I'm going to move that down just a little bit. And down just a little bit. Okay, so let's say that we're going to cut a bead here. Now, I'm not going to program the bead, I just want to show you why we are able to specify the starting and ending points. Okay, so there's going to be a bead right there. So in that case, we wouldn't want to machine this round all the way through. We'd cut all the material off, you wouldn't have the bead here. But we might want to cut from 0. This one here is going to, where we're going to, let's go horizontal. Okay, so we're going to start here, and we're going to start our taper at 1. Did I miss that? Oh yes, I definitely missed it. Okay, we're going to start it here on this corner, and we're going to go to here, so that should be 1 inch. There we go. And then we're going to start here again, and this, of course, is 16, but this right here is 14 point whatever, and this is 14.997. All right. So if we said, okay, we're going to taper from 1 to 16, it would machine this off. But we've defined the taper just knowing this position and this position, the ending position and the diameter here. Okay. But you can say only cut from 1 to 14.426 right there. And then you could create a second one that would start at 14.997 and cut to 16 on this same taper. So I don't have to come in and calculate exactly this starting point and diameter, and this ending point diameter, and this starting point diameter, and this ending point diameter, and so on. You just define the taper overall, and you decide what section you're going to cut in. So if we go into here, we would say, let's cut from 1 to, well, again, if we wanted to go to this point right here, we'd go to 14.426. Okay, and finish and save. So if that angle was too great, if we generate this code, it says...
Before you go further, Tracy, how do you get the second part of that on that? Because
okay,
you'd
add a second toolpath. Okay, so right here we would say let's do another round, and you can rename this. So I could say this is the second tapered round. Okay, and then we can position this where we want it. So I'd cut it, and let's rename this one. This is going to be our first tapered round, and then our second tapered round. Okay, so when we close this, it says, okay, first one's done. Second one here, you would put all the information in. It says if it's tapered, you say yes, and you would put the same thing here. It's going to start at 1 at 2 inches. It's going to end at 16 at 1.5. But your starting tapered position would be 14.997, and the ending would be 16. Okay, so it would be 2 toolpaths. Does that make sense?
Yes.
Okay, I'm just going to cancel out. I'm not going to bother finishing that. Okay, go ahead. Question?
Yes, when you're turning a taper with a flat cutter like that, obviously the tail of the cutter is making a line, so to speak, a minor line, is there any rule of thumb or anything of what feed you would feed that to get a better finish?
Okay, so let me see if I'm following. You have a bit, surface planing bit, for example, is 1.25. I'm going to put it by 2.5. We're just going to set it right there. And of course, it's got a shaft on it. But let's say that we're going to turn it around from this point right here. So you're saying it's leaving a little witness line right here?
On the back side of the cutter.
On the back side, so when you get to the other end, you're saying?
No, as you're feeding from left to right, the left side of the cutter will be cutting last as it's going down.
Gracie, I think when you first set this up, you said a 2704 to turn it around, and then you went on to the taper when you should have changed to a bull nose or something for the bottom.
Well, not yet. Not yet, Alvin. Okay, don't let me forget that. I'm going to come back and cover that because that's very important. But I want to follow up on this right here. So you said as this moves down along the length, like so, and it's turning it around, it's leaving a line here behind it?
Yes, kind of.
So you're seeing a spiral pattern?
Right, that's what I'm saying. Is there a rule of thumb of how slow you should feed it to eliminate that as much as possible?
Well, what you have in conversational CAM and Pro is that you have a step over. For the rough pass, it's typically 3/8 of an inch, and we don't care because it's just rough. And the final is an 1/8 inch. And if you use an 1/8 inch with this bit, you should get a perfectly smooth surface like it's been sanded. So if you're getting some kind of trailing edge with an 1/8 inch step over, these feed rates aren't really going to matter. I typically speed this up to like 1,000 inches per minute on my final step over, final pass of 1/8 of an inch. If you are getting a spiral pattern on it, there's a possibility your spindle is not trammed. In other words, it's not straight up and down from your plane. That can cause the back edge to cut.
Can I interject for a second, Tracy?
Yeah, please.
You get that, you're using the 1 1/4 2704,
Mm-hmm.
and you're showing it on a taper. That's why he's getting that spiral. You need to turn it around flat.
Oh, I see what you're saying, Alvin. Okay, right. So what I'm doing here is I'm just turning it around like this. Now, in conversational CAM, if you use this bit and this taper and everything, let's finish this out and generate that code. Okay, it's going to use the 2704, and the first section is just going to turn it around to that 2 inches in diameter. Then it's going to pause, and it's going to have you set the bed to a 0.95 degree, which is a 4.44 turns. And that'll adjust the bed enough that it'll still use that same cutter to machine that on around, because it's going to set the bed at an angle. And so this new angle will now be parallel with the surface. It'll be level because you adjust this end up. That's what the software will do. This is where the original question is, I can't do that because it says the angle was too great. See, you have a maximum degree, 4.44 here. Whoops. So we're going 4.44 degrees. And depending upon your machine, you have a maximum angle. Oh, check this out. This maximum bed adjust. That's not the angle. 3 point. That's okay. That's not degrees. That's the distance. 3.25. And we're only going 1.11 inch here. That's why it works on this. It generated the code. Now, if that angle is too steep and you cannot adjust the bed that far, then we have to do something like the round contour. Let me get out of that real quickly. Or the round or the turning vector. So the round contour, CCAM Pro may have some issues, and so I have to be real careful with this. I'm going to go ahead and double click on this round contour, because what we would do here, did I lock it up? Round contour. I seem to have locked it up somehow. Okay, we're going to go into here. All right, so this is the round vector turning. I really don't want to do that one yet. I want to come out of that. I really want to do the round contour. There we go. Okay, the round contour, you cannot use the surface planing bit, or you will get that trailing edge. it has to be a ball nose bit. So it could be a ball nose, could be a core box. Let's say we had a 1/2 inch core box and we wanted to do it with this. Then it can follow any contour, whether it's straight or contoured. Let's use a bit number here. So the section diameter here is 2, and it says what's the starting point? 1. The ending, or the starting diameter is 2, and the ending position is 16, and it's 1.5. And it asks for a contour radius, and this is where you put in 1 million inches. Okay, that's a massive radius, so that's virtually a flat area. And in this case, it doesn't matter if it's convex or concave. This particular thing would work. I'm going to put in here about 15 thousandths of an inch and go ahead and finish save. So that would actually work. Now you can put in multiple arcs in here for arc number 2 and arc number 3 and so on like that. But we're just going to do just one arc for the full length. You can do multiples. You can add those in. So if you got odd shapes with arc after arc after arc and they're all joined, you can do it that way. All right, so that's going to work with what he did because he could not do the taper. Vector turning is the last one. And the way that we do that, you have a question?
On the one that you just did, the contour turning, I presume you do not adjust the bed?
Right, on a round contour, well, let's save this and look at the code. So I'm going to, save that. I'm going to uncheck the first one because it does adjust the bed. Well, it would tell us to take it back to 0, but let's just generate the code for this one. There's no G code to save. Oh, I didn't generate. Right. So you notice that this one does not adjust the bed. And that's why it has to use a core box bit, because the surface planing bit would cut in the back and not in the front, wouldn't be parallel because the bed is still level. So this will actually look more like a copy lathe using that core box bit. Okay? So that's why the bed does not adjust. It's still flat. If we come up here and we say, okay, generate both of these codes, the bed here is flat. The bed here is tapered. Set the bed at 1.1. And then set the bed back to 0 or to level. And so this one actually cuts it round, flat, then adjust the bed and cut the taper, and then sets the bed back to level and recuts the taper using a different bit. The taper's exactly the same. But that's how the two are going to work. One's with the bed flat and one is going to be adjusting the bed.
Hey
Okay.
Tracy, how would you get that to work with that bead again? So you'd have 2 sections, let's say.
Okay.
Same part, just for curiosity.
Yeah, okay, so you would say the first contour would go to here, right? Now you have to be, this is going to be really tricky because what you're probably going to do here is if I have a ball nose and I'm going to say we used a 1/2 inch diameter like that, you have to be a little careful here because if I bring this bit down here, of course it's going to be right on that edge, but if I go all the way to that end point, it's going to cut half my bead off. And so this is going to have to end back here far enough that it doesn't cut into the bead if you use this technique. If it's a surface planing bit and the bed is adjusted on the angle, it doesn't matter. It will cut flat to there. So there's advantages to both. All right. So you'd have to do this one, and you'd have to stop right here. This would be your stop point, not here. Okay. The way that we'll typically do that is we'll either use a real small, like a tapered ball nose, so that we can get tied into this radius, and do this, or we'd use a big one like this. And for this one, I would use a round over with a flat. And so the flat would actually cut here and then it would round back over on the other side. Okay, maybe I can open one of those up if you not sure what I'm talking about. Oops, I don't want a bitmap, sorry. I want a vector. So we'll open up the vector and I'm going to go to documents I always put this all in legacy, not backup, legacy resources, sorry, legacy resource files. And so here's my router bit profile right here. This is the new one. And I know this isn't posted on the website yet. I'm still having some issues, but it should be posted fairly quick so you can download this new one. Okay, so what I would do is use, now I didn't draw the perfect bead down there, right? So I'm just going to, let's see, this has a 1/4 inch radius. I'm going to take this bit right here, Control C, Control V, and I'm going to send it down to my drawing. Come on. Come on. Come on. Okay, my computer seems to be locked up a little bit. It's thinking. Okay, that's frustrating. Okay, we're fine in here, so it's actually a spire that is locked up. Dang it. Anyway, I'd put a flat on there, and then you would answer your question. You would have, there we go. It just took a long time to think. Okay, so this isn't going to fit this bead perfectly, but you're going to get the idea. I would set this one right here to cut that bead, and over here it would be removed. But this way, you can see how if I'm using the 1/2 inch round nose to cut this down as a contour and not adjust the bed, I can stop all the way clear back to here if I want, and it will not run into the bead. And I would put that bit on the same thing there, Control C, Control V. So I might put this bit on the opposite side as well. And if we wanted to form the perfect bead, I'd actually go here like this, but you get the idea. So this bead wouldn't really be this size.
Will the program automatically calculate the height for that second cut? Or you got to figure it out like a measurement? You know, like the first one you showed us, it figures both. You know, it knows the total length. So if you do 2 sections, it knows. If you give it a second starting point, it knows how deep to start. In this scenario.
Yeah, the reason it knows how deep to start is because you programmed this entire taper.
Right. That's why I was asking, is there anything like that? If you do it this way, is there any entire taper thing or not really?
No, not really. And this one you are going to put in here the diameters and everything.
Okay, thanks.
The next system I'm going to show you will do this automatically, because what we would do is that we would, in fact, I'm going to go ahead and break this up. Okay, so I'm going to go into node editing, and I am going to maybe I'll go into node editing. Am I in node editing? Yes. Okay. I'm going to add a node about right here. Okay, so we'll just insert a point. There we go. And I'm going to put it down here about like this. And then I'm going to insert one down here as well. Okay, and then I can actually cut this right here, cut that vector, and cut this vector. So what I have now is I have, let's get out of that. Okay, I've got a vector that goes only to there, and then I've got a second vector that only goes here. Okay, so in this case, I would program this first one using a toolpath here in Aspire, and so typically, we're doing it's just a profile toolpath, and we're going to cut on the left of the line, and the cut depth is going to be very shallow. In fact, I'm only going to say, we'll call it a 1/4 inch. It doesn't really even matter. But what we do is we choose a particular vector turning bit, because we're not really cutting with this. This is just creating the radius of the diameter. So if you were going to use a 1/2 inch bit, I would use this one right here. Okay, I've got some background noise, so I muted. So if you have questions, then jump back in. But I just muted everybody. Okay, so if we choose a 1/2 inch, for example, then the 1/2 inch will cut that. It could be an extended core box, or it could be a round nose end mill that's 1/2 inch in diameter, and all those things. And so we don't need all of that, but I'm just going to add it in here. So here we go. We don't really care about anything here because we're going to program this all. Well, it's going to be programmed here, but then we're going to convert it in CCAM Pro. So we're going to cut on the left-hand side that deep with that 1/2 inch cutter, and we're going to call this the first contour. It's not a contour. I'm going to call this a tapered vector.
Tracy, can you resize the drawing? It's a little tiny thing down the lower corner.
Yeah, absolutely. Let's do this. I'll put it on 2D view. And here's the other thing I'm going to do. I'm going to take this bit, and I'm going to move them to a new layer. But I'll put it in the layer 1 or whatever, because then I can turn off my I can turn off my router bit layer, and we'll work in this layer. So now it's only this. It's much more responsive without all those vectors on here. So here's the bit now. So I have my first one, and it is going to be, if I double click on this again, it's just this vector here. It's straight, okay, and we'll calculate that. And then if I want, I can duplicate this. This makes it really easy because it's the same. Everything's exactly the same, although I will change the vector. Oh, and I need to change the start point. So let's go to node editing. We'll make this the start point. Okay, now I need to double check that the starting point was down here on the first. Yeah, because it's on the left, and this one's on the left. Okay, so that's all correct. All right, so now we're cutting on the left-hand side. Okay, and we'll change the name to number 2. Or the second. Yeah, do. So let's change this to second, and we'll choose the proper vector. Thank you for that catch. All right. So this is the second tapered vector. It is straight. It's not a contour. It can be, but it doesn't have to be. We click OK, and then we preview that guy. So that one takes that one off, and the other one takes this amount off. Now keep in mind the bed is still set level. It's going to turn this around, and it's going to leave this section right here, so you can machine a bead here if you want. Okay? So you can actually, I like to save out each vector one at a time. So if I'm going to save this first one out, I would save it like this. I think you can save out both of them. If Mike's here, he can correct me. But I always save out just one at a time. So we'll save this vector out. They're all recalculated.
You can put those vectors in the same file, and then it'll take care of it.
Oh, okay, it will. Okay, so we'll save both here like this, all right? And we're going to do a 3-axis, not a 4-axis, okay? And we'll save this toolpath, and we'll put this in. I'm just going to throw it on the. Well, what I could do is I could throw it into. Okay, so many of you may know now in Documents you have a CCAM Pro folder. And we have a project in here, and it's called Test Taper. So if I want, I can actually put these vectors right in here. So these are the tapered vectors. Okay? And then when you go back into CCAM Pro, and we go to this vector turning, this is going to ask us to select the G-code that we created. And so we'll go back to Documents, to CCAM Pro, go into my projects, into my test taper, and there's my vector for this project. So I just put it there because it'd be easy to find. It's inside the folder for the project. And the section diameter was 2, and this select the diameter. So when we click on this, it's 1/2 inch is what we want. So I'm going to use, for example, a core box that's a 1/2 inch in diameter, match the same one that I had in the Spire. And we'll call this tool number 2. Actually, it's the same as what we used before, so it can be tool number 3. That's fine. We're not. The Y position we can offset slightly. It'll give you a slightly cleaner cut, and I'm going to do just 0.010 of an inch, just barely. And everything else is. Everything else is good.
Why would you want to change the diameter? What would that do?
You can scale it inside here. So even though you programmed it, let's say you want to scale it so that instead of a 2-inch piece, you want to make it a 3-inch piece. Then you can change the diameter amount.
Would that be like from 2 to 3? Would you put a 1 in there? Like you're changing it 1 inch from what it was?
I believe so. Mike, does that sound correct?
Yes, it added.
Okay. Yeah, so if you're increasing it by 1 inch from 2 to 3, that's what you'd put in there. Right, perfect. Okay, now we'll save this. Now this one gives you a starting position, diameter thing. It's just to kind of give you an idea what's going to happen. Now, if we just calculate this one, generate the G-code, okay, then this is not going to set the bed on an angle. It's not going to machine it flat like we did with just the surface planing bed. It's just going to leave it flat, and it's going to cut, turning it like a copy lathe. It's going to cut these two vectors. Okay? So there's 3 ways to accomplish that. The first one, if the bed is if you can get the angle in it, use the round and taper, because then it allows you to cut right up to the bead with a flat cutter, so it's perfect. If not, then you contour like you did. That was mentioned here earlier, and you can do 2 contours, so they're in 2 different sections if you're going to skip this section. And then the last one is a vector turning, which actually converts it to a lathe using a G200. Or if you're using a Mach 3, it'll be called indexing, and you won't even be able to choose whether it's indexing or turning. It will just be indexing. See, on this one, if we come up in here, it asks, oh, I'm probably, let me go look at my machine, which one I'm programming for. Oh, a 3x5. So this one is a Mach 3 system. That's why I did not ask if it was turning or indexing. Okay, you'd only have that option if it's delta. They'll both work. One's faster than the other one. One tracks the A-axis. So there's advantages to both of them. Okay. Any questions? Does that all make sense? Everybody follow that okay?
I do have a question on that drawing that you did.
You bet.
That first tapered round where you tilt the bed, does that turn around with the bed level and then go back and cut the taper after you raise the bed?
That's correct. So let's just look at that particular G code. I'm going to generate that code and we'll see exactly what it's doing. You notice the bed is level. It did not ask you to set it on an angle. This grabs the cutter and this just turns it round to that 2-inch. Okay? And then it says set the bed on an angle. Now it doesn't change bits. It's still using the same bit. So it turns the spindle to the speed that was calculated for this right here, which is 16,000 RPM. And then with the bed adjusted. So with M0, that means pause. It's going to pause the program. It's just going to sit there. And it's going to come up and say set the bed to, I would say the 4.44 turns. That's going to be the easiest one to get it dialed in perfectly. If you don't have that hand wheel with the decal that does that, then you can do the degrees or you can do a dimension. Okay, but it's just telling you how far to adjust it to make that work. And then when you hit cycle start again, it's going to continue running the program. It was just paused while you adjusted the bed. And then with it on an angle, it's going to do they round it again on the taper.
So just out of curiosity, would you do the bead last after the taper cut when you're programming, or would you cut that bead first?
Yeah, that's a great question. I personally,
I guess my point is that if you do the bead before the taper, otherwise you got to take it back to 0 and then start cutting again, correct? You can't cut the bead on the taper.
Well, no, okay, that's a great question. Let's go back into manage our toolpaths here. We're on this part. Let's go manage our toolpaths. Let's add a new one. We're going to turn it with a tool profile. Okay? And we could, of course, adjust this anywhere that we want, but let's select that tool. Now, this is a plunge flat roundover, and it was a 1/2 inch radius and a flat. So a quarter inch radius rather, and 1/4 inch flat. It's this cutter right here. So we'll select this right here, and I'm going to give it a tool number 5, so I don't overtop. Section diameter is 2. X-axis position. Now we would take this off of this position right here. Okay, so it would be the 14 point. It would be the center of this bit right here is what we'd have to measure to. So if I measure that, I'm just going to say it's 14 inches, or we're just going to assume that 14 is right in the middle of this instead of doing the dimensions. We're just imagining. Okay, so we're going to end right in. We want the center of that cut to end at 14. Then we go in here, we'd say 14 inches, and we'll use the profile height. That is correct. And then it asks here, is it tapered? And we're going to say yes. And it says, well, tapered start position, that was 2. And it was 1. I'm sorry. That was 1. And the diameter was 2, and the end was 16, and it was 1.5. Okay? And we'll finish this now. Now, I'm going to just generate the tool profile G code, so we can look at just that. Notice that it sets the bed at 4.44 turns. So the bed will be up on its angle for this. So I would probably turn everything. I do everything that needs to be done while it's in its flat, and then I do the turning around it with the taper last, and it would set it on the angle, or not second to last, and cut the two sections before and after the bead, and then I would do the bead. That's how I would personally do it. And this, if you had this, well, let's do this first taper and the turnaround. Okay, let's generate these two codes. So you notice it turns around with the bed flat, sets the bed on an angle, and then it does not stop to have you set the bed again. It's still on the angle as it machines that bead, because it set the bed to taper, because the bead is cut on the taper that we programmed right here. So yeah, you can do beads and coves and any router bit profile on the taper. The advantage of that is that if you look at this right here right now, this bit is not actually parallel with that surface. That's a problem. But by setting the bed up on an angle, the bottom of this bit will now be perpendicular, I'm sorry, it'll be coplanar or parallel to that surface, because it'll be tilted up. Did that answer your question, Alvin?
Yeah, it does. It just seems like that bead would be off-centered when you were done turning, but maybe not.
It calculates when you set the angle in, you have to say, you would come back, if you know this is a 1/2 inch flat, then you would have it's programmed at a 1/2 inch back from this edge, would be the center of that bit. And from this edge, it would be a 1/2 inch further. That would be the center point of this particular cutter.
I've got a new question, new topic.
Yes.
I've got one of my students through making a dovetail box. At one time he said CCAM Pro has I don't know what you call it, a toolpath for that.
Uh-huh.
Where do I access it?
Okay, so if we go into this project, this is a test taper, so this is a project we only had for tapering, right? Turning around. So let's create a new one, and let's call this a box, okay? And we can use any of the workstations, but you would definitely use the vertical workstation and possibly the horizontal workstation. So I'm going to put those both in here and say yes, okay? And then we're going to select that box. Now here's the vertical, for example, and if I go into Manage Parts and I say let's create a new part, this is going to be the box. Okay, now let me Mike, catch me if I make a mistake here, okay? So the blank description, it's not just a single piece of wood like normal. We're going to say, you can only do this in the vertical, we're going to say we're creating a box. So the part is a box, but it's made up of 4 components, a front, a back, and 2 sides, okay? So we're going to choose box here, and we can autofill if we check right here. So let's say the length is going to be, let's say it's 10 inches. And the height is going to be, let's call it 4 inches. Or 3 inches, okay, 3 inches. And the thickness could be a 1/2 inch, could be 3/4. Let's say it's a 1/2 inch, okay? Now that's the front and the back. Right, now we go to the length of the side, and it's going to be, let's say that it's 6 inches, okay? And then the front height, we're gonna say everything is 3, and we're gonna say, so we're gonna use all 1/2 inch material, all 3 inches wide, but the fronts will be 10, front and back will be 10, the sides will be 6.
Now name your part.
Oh yeah, because if you tried to save it, it'd tell you that you can't do that. So we're gonna name this. We're gonna call this the box, okay? Whatever you want to call it. And now, if I wanted to save this box into my database, I can, so I could come back later and use the same component, the same part. It's a box, but in this case, we're just going to say, okay, save it. So again, it has 4 parts here, and so now we're going to close this. And so now there's a vertical table, and there's your box. So this is where we're going to come in here and start adding our tool paths. And it's on the vertical, all we have in here is just, it's all joinery currently. Okay, we'll add more to it, but right now it's just joinery. And there are dovetails, and the dovetail will let you choose either through dovetails or half blind dovetails. Okay? You could also do just box joints, which, to be honest with you, I would recommend that you start with box joints because they're just straight cuts. It's real simple to do. And so I'd probably just do box joints as a practice. And then when you feel familiar with how you've set up your parts, box joints are all cut, by the way, on the vertical. Sometimes we'll set up for dovetails, vertical and horizontal. Okay? And so if we chose dovetail, we just add 2 there and we can close that. And then you would come in here and program. And so you would choose the type, the half blind or the through. Okay, let's do through. Select a dovetail bit. Okay, so I'm going to come down to dovetail. And okay, I like 14 degrees, but I'm going to use the 1/2 inch diameter because we're only using 1/2 inch thick wood. I think that'll look nice. So we'll choose that one. Bit compensation. You might want to make a test cut, and if it doesn't cut quite wide enough so they don't fit, it's too tight of a fit, you can compensate for that right here. I'm going to leave it at 0 for right now, but you could put 10 thousandths in here or 5 thousandths or whatever you needed. And then here we have a dovetail step over. So how far the step over is how far the router bit will overlap the last pass. Typical value is approximately 40%. In other words, if your dovetail is actually wider than 1/2 inch, it's not just cutting straight through, then it's going to take that bit and it's going to cut across there with a step over of typically 40%. So my 1/2 inch would be, half of that, 50% would be an 1/8, or excuse me, a quarter. And so I might go, 0.375 here or 0.3 or something. It's typically about 40% is what it says here in the instructions, and that's what we found works really good. Dovetail free rate 80, pin spacing is even, half pin size is 0.5 pin size. So these are basic defaults, but you can change these if you want. Calculate the number of pins; it'll do it automatically for you. Set proud amount. I'm going to say like 10 thousandths or 5 thousandths of an inch, so I can just sand off the ends of the tails and the pins. 0.005 as well here. Select end mill. So if we're going to use an end mill to clear out or cut the actual part of the dovetail, then we would do this, and I'm going to use maybe a 1/4 inch end mill. So let's go to end mill. I'm going to use a end mill down 1/4 inch.
So would I need to do the end mill? Would I need to waste out?
Yeah, it'll waste through the center of the dovetail cut, and then it'll cut through the dovetail. Is that right, Mike?
I'm asking if I need to. If I can avoid a tool change, I'd really like to.
No, you're gonna have to have a tool change.
Okay. End bit compensation. I'm not gonna. We don't have to mess with that. And we'll step over. Okay. Again, about 40%, and it's a 1/4 inch. So I'm going to say 0.1 pass step. Okay, and you can put those in and then just finish and save. Whoops. The end mill step over is invalid. Okay, so let's see.
Put a comma.
Oh, did I put comma? Station pass step point. It looks like it fixed it. Okay. So you can see here, it's got the dovetail side panels, front and side panel back, front panel right side, front panel left side, and so on. So it gives you all. So you don't save these all out as one tool path. You would save this out, save this. I like to save to the G-code vault, but if you want to save it to a flash drive, you can save it to here. It will write it to the vault as well. But it always keeps a copy of all your toolpaths that you create. So you would save that one, then you would save this one, and then you would save this one, and so on. And then you could set up and run all of these. Did I miss anything, Mike?
That's it.
Okay.
Tracy,
Yes.
Can we see the G code?
what,
Sure.
Tracy Floyd, what's the difference with this and the tails and the pins?
Well, okay. And I always get confused. Which one the heck is a pin and which one's a tail? One has to be cut with a dovetail bit.
Okay, the pins are cut with the end mill, and
Okay.
the tails are cut with a dovetail bit.
Okay. And this one uses both. So this is doing the dovetail front panel left side.
If you go to Corbin's documentation, he explains the difference.
Oh, okay. I'll have to do a little research and figure out which ones are pins, which ones are tails, and so on. But yeah, you can cut.
Usually he said the sides are the pins and the front and back are the tails.
Oh,
That's
okay.
the way you cut it.
Okay. Okay.
I thought the sides were the tails because when you pull on the drawer, they have to lock. So the tail has to lock into the front of the box.
Yeah, the sides are the tails.
For a drawer, I think that's right. For a box, you may want to show off the tail on the front of the box.
Oh yeah, good point. Well, there's
Just don't
Corbin's
pull on the front.
documentation is really good. He has, I don't know, 70-some pages for different cuts, but he shows a lot there. His documentation is great.
Pin the tail on the donkey. I have a question, Tracy.
okay.
Didn't mean it was crap.
Let me just show this real quickly.
Yeah, go ahead.
I'm sorry. What are the shreds? What the freak? Oh crap! I got this stupid. I don't want this. Close. Try. I don't want to. I don't want to ask a question. Why am I? Let's get rid of the AI assistant. Okay. Okay, so here's your documentation for your dovetails inside the help. And it's built right into the program. Okay, and the way you get to that again, I'll just show you real quickly. You go to help and CCAM Pro help, and then you're going to look up the dovetail joint, and it's going to give you all of the information you need here. It's pretty intensive. Okay, I'm sorry. What was the other question? Next question?
Not pertaining to this, but I was looking to use a spiral ball nose or bull nose.
Right.
And I noticed in the tool library there's nothing for that. And I know when you did one of the tool paths for the new, you went to the core box at the same size.
Yeah.
Is that what we do to do a spiral ball nose?
Yeah, that's what you do now, and that's a. I'm glad you mentioned that. I will get a spiral end mill because. Okay, so this is a case. Let me explain what happened in this case a little bit. This is a case where he's not working on a little tiny spindle. This is a pretty good sized piece. This is like 7 inches, right? And a lot of material gets removed, and so you're cutting really deep on these things. So we wanted to use a larger bit to remove, waste a lot of material and stuff. And we wanted, if you have a core box bit, a standard core box, it's only, the cut profile height is the radius of that ball nose, okay? And so you got to make maybe several passes to get down. Now they do have an extended core box. I don't have them in here, which is something we could add into this, so if you want to use that. But what I really like is the end mill that has a ball nose on it. So instead of a standard end mill, it's got a rounded nose. And I like the idea of adding that into the tool database here. Now it's possible you can say add a new, and you can come down here and say other, and program something in. You'd have all the details. You just wouldn't have any pictures, right? for it. I've talked with the programmer about being able to actually have you take a picture of a particular shape or bit and put that here so it displays here instead of this drawing that we do. So if you wanted to add pictures in, but you can't do that yet. For other, it would just say picture not available. Okay. So all I'm doing right now is, even though he's using a ball nose, which is very long and has a 1/2 inch, I just use a 1/2 inch core box. Okay, because all we're really looking at is the shape of here, right here, to make sure we cut we're cutting tangent to the arcs at any point, and that's why we have to have this round nose on the bit. Okay, I like the idea of adding that in here though, because then it's going to tell you exactly what to use in your program. Right now, it would just say core box.
I tried to add that in there. I don't recall if I went to other, but when I went to my tool pathing and I went to add, it wouldn't let me, and that's why I ended up just going to a core box for my 1/2 inch bullnose down, or 1/2 inch spiral bullnose, or ball nose.
Okay. All right, so what I'm going to do here is I'm going to give it a tool name, and I'm going to call this I'm going to call it an end mill round nose. Okay, now the only problem with this other, I'm not going to do this because it does not ask for the oh yeah, it does ask for a diameter right there, but that's not really. Let me look here, see what we're asking here, because different tools will ask for different information. This asks for a tool diameter, profile height. So it worked.
I actually went and pulled all the parameters from Magnate and punched them in, and it wouldn't recognize it.
Okay, I'm just going to try this. I'm going to call this end mill round nose. 0.5 diameter.
Spell check. There's a
spell check
that we did. I don't know if people can see that, but
round rose.
the monster.
Okay, manufacturer ABC. Tool manufacturer ID. Oh, manufacturer tool. This is a tool number. I put 1. I'm sorry. This will be the XYZ. That's the tool manufacturer ID. Okay, so we're going to say 0.5, profile height 0.25, number of flutes 2, let's put it 18,000 RPM, maximum pass depth. We're going to call this 0.5, feed rate 150 is our default, plunge feed rate 40, chip thickness.
On your profile height, wouldn't you have an inch or two if you had a good sized ball nose?
Well, okay.
That's the question.
Yeah, that's the question. The profile height here is very critical, that it's just the radius of the round nose. That's the way.
You could put a 2-inch ball nose in then.
Yeah, so you could put something larger, but now the diameter.
Length, 2-inch in length ball nose. Like a bit.
Well, actually, you're right. That doesn't really matter. So our profile height. I think it's working off the diameter.
Instead of another, why wouldn't you put it under end mill?
You could, but the picture would show a flat end mill. You could put it under there, and then just under notes right here, you could put that it's a round nose end mill. So you would see it in the notes, but it wouldn't show it in the picture. And that's why the best thing to do is to create a end mill with a round nose, and then there'll be a category for that specifically, instead of just end mill up or down, or let's see, we have a ball end, but we don't have a ball nose, so I might call it a ball nose end mill or something like that.
That's what Magnate calls it.
Ball nose end mill.
Yeah,
okay.
They call it a ball nose end mill.
Okay.
So when you do what you're doing there, Tracy, on the tool setup, when you go to hit select, it kicks out. Mine kicked out the chip thickness.
Okay, so I'm going to say save new, because we have to say save new before we select it.
Right.
And then it'll put it in the other down here. So if we select this, then we should be able to select and it should work fine. Make sure you save new before you hit select.
Right, and I don't recall that that's what I did.
Okay.
I think I was just trying to save.
Okay. Okay. Well, we're about there. Is there any last questions or anything we can cover real quickly before we end the class?
One more quick taper question.
You bet.
I've got a whole bunch of ballasters to do, and they're tapered from 1 1/4 to 7/8. And can I just set the bed at the taper angle and not do the turnaround and then set the taper up and then go back to 0? Can I just put everything in on the taper and just turn it from a square blank at the correct angle?
That's a great question. Mike, are you still there?
Yeah, I'm still.
Okay, I want to ask you this. If we go to the turning center, we manage part. Okay, let's take this part is not as big. Let's go actually go manage the part. So if I go to this one right here and I say edit, and I make this round, so it's 16 by 2, and save this. And then I go in here and I say turn around, which would be this one right here. And I put all this information. Let's just check and see what happens. I don't want to generate all these. What I want to see is if it will, just because it's already turned around, will it just say set the bed on an angle? Yep, there you go.
But it said, when you had that up, it said turn around and you had no.
Let's go back in, make sure I didn't do it wrong. Not as big. Okay, so this part type is round. Okay, oh, I see what you're saying. So when I went into part, not as, let's manage the toolpath. Let's close that. Okay, let's go to here. You're saying tape turned round. Okay, so this is kind of a double whammy because it has been turned round. That's the part is round to start with. Now, okay, but if the part is round, it's 2 inches, and you say, has it been turned around? And you say yes, it's going to ask you for the new section diameter. So let's say the original part was 2 inches in diameter, but you turned down at least one part of it to 1 1/4 inches. Then that's what you would put in here if you were working on that diameter that's 1 1/4 inches diameter. So if you have not turned it any smaller, it's just the original round 2 inches, then you don't have to put anything in there. You say, no, it's not been turned round, even though it is round. So this is asking, have you turned it round in the machine? Or if it was round when it came in and you said it was a round part, you wouldn't have to. Does that make sense?
Yeah, it does to me. I thought that he said that he had a square part that he wanted to taper the bed while it was square and just go around all these things.
Okay, if that's the case, you can do that in CCAM Essentials.
Well, could I just lie about it and say that it's been turned around, but use the dimension of the blank as the diagonal dimension of the square?
That's what I was thinking.
Say that one more time, see if I'm following you.
If I take the diagonal dimension of the square blank and input that as the turned round diameter and lie to the software and say, yes, it's been turned round, but just give it the diagonal dimension as the diameter.
Okay, let's check this out.
It's just going to have to do more passes, but so be it.
Okay, let's take this part.
The same amount of wood has to be cut, so I've done that before in other applications. The diameter now would be 2.828.
So you would do that in the part itself, is what you put in?
What he's doing is taking the diagonal of the square, the distance in the diagonal, and then he's calling that the round. and running the taper off of
The
it.
round diameter, he's calling that the round diameter,
Okay.
even though it's not.
So this is the question: is if I say yes, it's been turned around, then I can't. Then I would have to have put the diameter into the part itself to begin with.
Yeah, if it's a 2x2 part, you measure across diagonally, and whatever that measurement is what you put in as your section diameter.
Yeah, 1.404 times 2. So
That's a 2.828.
yeah, there's obviously two ways to do that. You can simply draw it and measure it, or you can take 1.404 times the section, and that'll give you the swing diameter. So let's go. We'll make it 2 inches square.
So I guess the question now is, you have to call it that diameter in the part itself, or you just call it that diameter in the part of it? Where should I call it diameter in the part itself?
Yeah, I think you'd say the part itself, because otherwise you'd have to say it's been turned around to this diameter. And that I don't know if you can lie to it and do that. Let's say that you say it has not been turned around. Oh yeah, let's say it has been turned around. What's the section diameter? And you put that new number in here. Let's say it's 2. What did you say it was? 2.2?
828.
828. You put that in here. And then you put your taper in here. Finish and save. Let's see. Okay, I guess I skipped a minute. Blank swing diameter 22. Exceeds 10. Okay, so somehow 2.82.
What are you calling the part diameter?
Let's go look. Maybe I
Since your
entered.
number's up wrong in the part,
Yeah, maybe I put the wrong number in the part diameter.
you reverse the width and diameter, or length and diameter.
Oh, that's hilarious. Let's try that. Okay. Okay, so now we're saying it's turned around to that diameter. And we just want to generate that first one. Set to bed. There you go.
It doesn't care that the part diameter itself is actually less than that diameter you're turning to. It doesn't really care.
Yeah, because it's working off the numbers that you put in that has been turned to, not the original. It only works off the original if it's coming off that original. You're right. Interesting.
Put an undue stress on the bit as it goes from corner to corner before it's physically rounded.
Yeah,
No, it's gonna make several passes.
Yeah, in this case here, it's only making 2 passes. So if the part's big enough, now you can. Let me go in and look at this real quickly. If we go to this bit, we can say the maximum pass depth is 1/8 of an inch, for example. And then let's save this and look at the code and see what we got. Yeah, I've still got 2 passes. Yeah, that's okay. So, yeah, it's going to make a heavy cut because it thinks it's been turned around and it doesn't know that the corners are there. But no, the corners are there just as if it was round to start with. I think you'd be okay.
So the bigger the diameter that you get into with a square part is, you have to go in and waste away the edges and put in your notes to turn it 45 degrees to take those edges off, because it'll actually shut your machine down on maple or oak or white oak or hickory if you try to do a big
Long.
waller out on a square part.
Yeah, the bigger the diameter, of course, the more torque it's going to require, and so you're absolutely correct. You can make smaller pass depths to get down and kind of
Maybe the only reason that it 2 passes is because your tapered diameter is so big, you'd have to make it smaller than what your square is, correct?
If you were making it round to begin with, you're making a pass, and then if you tapered it, you're still making 2 passes. So you're not changing anything.
Yeah.
Yeah, I think that's right. You knock off the ends, the corners when you do a normal turn around. It's about the same thing.
Yeah. Well, I'm gonna need to play with this a little bit more. Really pushing the basics of it. All right. Oh, cool. Okay. Well, go. Another question?
Sorry, Tracy, I have one more question, and it's kind of an error that I got. I have a 3.5 inch round piece already turned.
Okay.
And I wanted to go in, and I wanted to take a 2704 and come down to every 3 inches, take it down to 2.5. Everything was fine, went through, got the G code, did the import into CCAM Pro for the turning. Told me I had to reach out to you guys because it was beyond my. I don't remember exactly what it said, but it said that I had to reach out and I had to abort the code.
Okay, can you send me a copy of the
Sure.
export your project and send me the whole project so I can open up and look at it. Now let me ask you, it was round and you were turning section of it to a smaller round?
Yeah, basically what I was trying to do is I want to keep the 3.5 inch round part, and then I want to cut 2.5 inch dowels to fit down into some pieces of logs to raise a bench seat up, kind of a spacer.
And then you're gonna part that, so you're cutting tenons, so you're cutting multiple parts and then cutting it like that.
No, I'm just cutting the dowels. But when I imported it, everything went fine until I went to run it, and then it said that it was I had to reach out to.
So when you put it on Delta to run it, that's when you got the message?
Yes.
Okay, send me the code then, the G code, and let me put it in my Delta and see what I'm seeing. Okay.
Yep, will do.
Okay, great.
Perfect. Thank you.
Alrighty. Well, we're kind of...
Are you going to post these classes?
Yes, I am. So I have them all recorded. I'm going to post them on my own YouTube channel and send you links to them, okay? So that you can view them. So I just got to set up my own channel. Alrighty. Well, I'm going to go ahead and close this down then, and we'll see many of you tomorrow.
Check the chats.
Oh, yeah, great. I always forget. Thanks. Okay, the first one is from TL and Russell. Let's. We need a phone call and just kind of plan things out for you. As far as the beta test for the table, Alan, I'll be sending those out as soon as I have it in CCAM Pro and in the others as well. So I'm just finishing off the files and then I'll send it all out to everybody. Where are you in the new door kit? Well, that's a great question for Andy. I think he's made up the prototype parts and he's got to do some testing. Would you? I don't see who this is, but it's iPhone 77 asking about the new door kit. If you would contact Mosiah Technical Support, he'll be able to get an answer from Andy for you. Kind of a status. You can create a support.
I'm on that list too to get that, and I was wondering where it was at.
Okay. And when will these classes be posted? Yeah, as soon as I create my own YouTube channel, that I'll just throw them in there temporarily. Okay. Well, then I'm going to go ahead and close this down, and we'll see many of you tomorrow, and anybody that wants to next week for another. So if you have questions on CCAM Pro that you want me to address specifically in the class for next week, if you drop me an email, Tracy, Tracy, at legacywoodworking.com, I can kind of prep for those that class a little bit beforehand, right? All right, with that,
Subject line,
subject line, say CCAM Pro Class.
Oh, but it's so much more fun to watch you squirm and do it ad hoc.
Make a fool of myself. I do that pretty good, right? Okay. All right. Good enough. Well, I'm going to shut this down. I'll see you guys all later. Thanks.
Thank
Thanks,
you.
Crazy.
All right.
Thank you.